Welcome everyone. In this video I'm going to show you an improved version for navigation in menus. So in one of my previous videos I showed a simplified version of this. I was using a few LEDs and a rotary encoder to switch between different options in a menu, but that was all. But here I'm going to show you by using a display, and this display is a large 20 by 4 LCD with an I2C connection, so we just need 2 wires, and the 20 by 4 means that we have 4 lines and each line has 20 blocks, so we can print 20 characters in each line. So that's very nice. And what we are going to use here is a rotary encoder, and I updated this by using 100 nanofarad capacitors between the CRK pin and the COM, and the DT pin and the COM, and also between the switch pin and the COM, but for some reason the button of this rotary encoder was not so reliable, so I just use the rotary encoder part of this rotary encoder, and I use a push button here to switch things. So what we will do here is we have also a microcontroller. I'm using an STM32 blue pill, but we can use an Arduino. I will show you in the code what you should modify if you want to use it with Arduino, but it's very simple. So you can see that this is a very simple circuit, but the idea behind it can be upgraded or improved in such a way that you can implement quite serious tasks with it. So what we will do is that there will be a menu displayed on this screen, and we can step in between the different options, and we can enter the different options and modify the values. So I just connect this to the power, and you can see what happens. So now we have some information here, and then this is the menu. And I assume that you should see this display very clearly. So as you can see, we have menu 1, 2, 3, 4, and then these numbers here in this column is basically a value which we can modify with the rotary encoder in each point. The C and T means count, and it is 0 now, so I'm just displaying the number which corresponds to each line. So if we are in the first line, we are at the 0 line, because the numbering of the lines in the code, for example, it starts with 0, so we stick to that. So now it's 0, and when we step to the menu number 4, it should be 3. And you can see that we have this small larger sign or symbol here, and that is our arrow. So when I rotate this rotary encoder, this arrow will be in front of the point which we are at a certain moment. So I just show you what happens. So now I switched this by one click, so we step to the next point, and you see that the counter value increased. So I switched it again, and we are in the third point, and you can see that the counter is 2, because 0, 1, 2, and that's 3. And now we are in the 3, so that is menu 4, because 0, 1, 2, 3. So that's the 4th point. And I implemented the code in the following way. So if I increase the clicks, it will jump back to the 0 position. So this should be here, the arrow, and the counter should be 0 now, as you can see. And if I do the other way around, so I decrease it, then this should jump to 3, and this should come back, as you can see. So you can see that this goes very quickly, and what we do is we only update the display in this column and at this block where we have the number which is currently showing 3. So why we have this button is the following. So when we select something, let's say we select the second line, menu number 2, then we can enter it. So I pressed the button, and now the arrow switched to X, which means that the menu point here, or the position, is now selected. So now if I continue with the rotation, this number stays number 1, but the 0 number should increase or decrease depending on where I rotate it. But I coded this in a way that it can have a number between 0 and 100, and then it will reset itself. So now let's increase it. And you can see that now I can increase the number or decrease. So we entered this menu. And if I click again, then we step back one, let's say, level, and we will be able to change this number here. So we come back to the main menu and we can select among the options. So I come back. So now the X became this arrow again. And now we change this number here. So as you can see. So if I go, or if I stay here, I enter again, and then I increase the number. Or I show you that if I decrease, after 0, if I keep going backwards, then 100 should come. You see? And then I decrease. And then this works with all of these things. So I go here, enter, modify, exit, enter, modify, exit. And then I can go. And of course, these numbers are memorized as long as we have the microcontroller on. So we can enter again, and then modify it, and then exit. So just a few sentences about this system. I will put this drawing on my website, of course, but why do we need this? So I have a lot of projects with stepper motors, and I also have a lot of projects with Peltier coolers. And recently I made a controller for Peltier coolers where I could control the goal temperature, so the temperature that I want to reach with the Peltier cooler, and then I can turn on the power supply and give more and more power to the Peltier cooler automatically and approach that goal temperature and of course finally reach that. So far, most of those parameters which were like participating in this cooling control were pre-programmed. So I programmed the interval for the refreshing of the measurements. I also had my own limits for the maximum and minimum temperatures and so on and so on. But I decided to make that fully controllable with this kind of system here. So for example, that can be one option where we can use this kind of menu, but also for stepper motors. If we are using the Excel stepper library, we can define the number of steps, for example, the number of steps to step, turn the motor on and off. We can define the speed, the acceleration, and so on. So there are some details. So for example, if we use this kind of strategy to control the stepper motor, we can, let's say with this kind of system, we can set up the speed, the acceleration, and the number of steps. And then we can enter another menu and just enable the running of the motor. So the motor will run with the defined speed, the defined acceleration, and the required amount of steps. But for that, I wanted to have like a precise control over these things. And that is basically the first step for that, to build such a menu. But I did not want to squeeze that information in that video because it's two different topics. So how to control a display and how to save all the variables and how to read the rotary encoder and the switch. So it's a rather complex process. So I decided to make a separate video for that, which is this video, and show you all the things. And then in the upcoming videos for stepper motors and Peltier coolers, you will already have a video where I explained these things. And we can focus on the stepper motors and the Peltier coolers more, or maybe something else. So once again, with the rotary encoder, we can navigate in the main menu, and you can see that we change the arrow or the position of the arrow on the screen. And once we are satisfied with the selection, so we want to modify the menu number 3, we click on it, And if you have a good rotary encoder with a good switch, maybe I just have some bad switch in this, you don't need the button, of course. So we select the number 3, and now since the X is displayed there, then we modify the value. And if we are satisfied with that, we just step back. And now we are here. So this is what happens. And now, of course, this should be shown behind the scenes. So what is happening in the microcontroller here. So now let's go to my computer and let's check the code for this. So let's look at the code quickly. As I said, we have the 20 by 4 LCD. So we still use the same liquid crystal I2C library, but here we have to redefine the numbers. So previously, when I was using the 16 by 2 LCD, I had 16 here and I had 2 here. Here in the comment you can also see what are the SDA and SCL pins for the STM32 or Arduino, so you have to connect the LCD accordingly. So then we have a menu counter here which will count the position, or which will keep track of the position of the arrow, and we need a variable for that. And then we have values for each menu. So we have the menu number 1, 2, 3, 4, and we need to store the values for them. So that's what we have here. And then we have to make sure that we know that the menu is selected or not. So we have to make a boolean for that. And yeah, as I wrote it in a note here, when we are navigating, we are using this symbol, but when we selected the menu, we use an X there, and the X stays there as long as you don't push the button again. So now we have to define the pins for the rotary encoder. And now, as I'm using STM32, I use this kind of code definition. So we are on the port B, and we are using the 3, 4, and 5 pins. On STM32 Blue Pill, it doesn't matter which pins you pick, more or less, because each pins can be used as an interrupt pin. But if you are using an Arduino, make sure that you use one of these pins, 2 or 3, because they are the only pins which can be used as interrupt pins. So you can see here that I put the CLK pin of the rotary encoder on the port B3, the DT pin on the port B4, and I put the push buttons pin to the PB5. And we will need some variables to store the status of the rotary encoder positions. So that's what they do. You will see it in the code. And we have 2 booleans again. One is to refresh the LCD, and the other is to refresh the selection. So I will explain these in more details later. So now we go into the setup. And of course, we have to use these pins as inputs, and we use with the input pull-up resistors, all of them. But I'm using pull-up resistors, but yeah, the more the better, I guess. So we will allow it here as well. And then this part basically just shows you some startup menu and startup information. But then, after waiting 5 seconds, I erase the whole screen, and then I will print my own things. And what I do, I just print within this function, I just print the stationary parts, which will never change, so I don't have to update those things. And after that, I will refresh only small sections of the LCD. More precisely, I just refresh the numbers one by one. And then we have to read the current values without moving anything of the different pins of the rotary encoder. So we do that here. And then we have to define the CLK pin as an attach interrupt pin, and also the push button will be defined like that. And as I said, I'm using a separate button, but if your switch button works well on the rotary encoder, if you are using similar kind than my rotary encoder, then you can just use that here, and you don't need a separate button. It simplifies the things a lot. So what we do in here is that this will be the interrupt pin, so the rotary CLK, which is defined here, so that's the PB3, and then that will start this function. So if there is an interrupt coming from this pin, we enter this function, which is implemented here, and we will look at the change. So whether it goes low to high or high to low, we will pick that thing up, pick that event up, and trigger the rotate function. On the other hand, for the push button, we obviously start another function which has the push button name, and then we just look at the falling edge. So when it goes from high to low, we will start this function. And basically this depends on the wiring. So if you pull your button to ground, or more precisely you pull the pin which is connected to the button's output to the ground, then you are looking for falling. But if you pull it too high, then you should look for a rising edge. So here you would write rising. So then we enter our loop, and I tried to follow my general practice, so I did not want to clutter up my loop here too much. So I was just introducing some condition checks and also very few functions. So first of all, this part. So if we have to refresh the LCD, then we update the LCD, and also if these function or these are not true, so I could have phrased this condition here differently, but it's too late now. So if these are basically not true, so when we are in the else, we also update the cursor position, and we set this thing back to false. So if we don't do anything, we will not enter this part in the next iteration of the loop. And also, if we have to refresh the selection, then we update the selection as well. And again, we make this variable false, so we don't enter this. So generally, when you don't do anything, the loop skips both of these conditions and both of these things. And it enters only when this or this boolean becomes true, and it just enters once. So now we enter the more complicated part, and I will not explain the whole thing because it's just rinse and repeat for most of the menus, but I will just explain the first, and you will understand the rest because only the variable names within these things are changing. So if the menu 1 selected is true, which means that when we were in the first line on the display and we pressed the button, we basically selected that menu. So if we selected it, then we can enter basically this part of the function, which is now highlighted. So then we save the position of the CLK pin, and then we do some kind of investigation between the recently read number or condition and the previously in the setup, the previously measured value. And what we do here is basically we see if the rotary encoder fulfills this condition, and based on that we just enter here or skip it. So then if this condition is true and we are allowed to enter this part, then we check this DT part as well. So if these are not equal, then we enter this part, and then for us, for our code, this means that we are going in one certain direction which should increase the value, And what I did here is the following. So if the value is smaller than 100, then we can still increase it. So we are allowed to increase it. But when it would become 100, then we zero it out. So that's what I showed you, that if I increased it and I went above 100, then it went back to 0. And the same applies in the other direction when we are decreasing the value. So that happens here. So if this is not true, then we enter this part in the else. And then we see that if our number is smaller than 1, that means that we don't go below 0 basically. So instead of printing -1, we will print 100. So we go like in a cyclic way. Otherwise, if we are, let's say 52 is the number, then we can just decrease the value by 1 increment or 1 decrement. And then we just store the last status of the CRK here, and that's all. And what happens for the rest is basically the same, but we just update the numbers or we just update the variables here. So menu 2 is the same, 3 is the same, 4 is the same, and basically the menu counter is the same. It's only different from the purpose. So this is either increasing or decreasing the value of the counter, and basically this counter changes the position of the arrow. So when everything is finished, so the menu counter, the menu 4, 3, 2, 1, one of those are performed, then the code is here, and then the next thing that the code will do is to set the refresh LCD to true, which means that when next time the loop starts to go, it will see that now this is true, so it can enter. And basically that's what. So we updated the value of one of these variables here, here, or further down. And then therefore we have to update the values on the screen. So we have to show the most recent values. And that's what will happen. So since this will be true, then we can update the LCD. So this is the rotate function. And then we have the push button function, which is basically triggered by the push button or triggered by the button on the rotary encoder if you have it like that. So I just made a switch case statement here, and we just see what is the counter. So we see where is the arrow standing. And whatever we do, if we enter or exit, we just have to change the status of a variable. So if it was true, it will be false. If it was false, it will be true. And that's what happens here. So actually here it was originally it was false, so then we will switch it to true, and that means that we are in the menu. So when the code will have this part up here, then it will enter this part and it will update this selection. So then it will reach this function here, and then it will check which menu is selected, so which Boolean variable became true, and based on that it will enter one of the lines and it will replace the arrow with an X. So this is what happens here. And then you can see that the LCD print happens here, so we don't have to update the screen with the other function. So this is done. And then we have some other functions. So the print LCD, this is the thing which runs in the setup. And you can see that we just go to a certain position and print the menu numbers 1, 2, 3, 4 and the C and T. So these are the stationary parts. They are not changing during the running. While the microcontroller is running, they won't be changed. And then we have the update LCD, which constantly being called when something is changing in the variables. So if any of these variables change, you can see it here, then we just update the whole let's say, dynamic part of the screen. So we jump to a certain part of the LCD, and then we write our value. And here there is a trick, and I just show it for, or explain it for one line, because you can see that the pattern is the same. So first we have to go to the desired position. So we jump into the block number 9, which is the 10th block if you look at this screen and count the physical positions, because we start the counting from 0. So you go there, and you have to erase the parts where you expect the numbers to be stored. So if you have a 3-digit number, then you have to have like 3 spaces. So 1, 2, 3. If you have more, then you have to add more. Or if you have less, you have to add less. Why? So I show you. So when you print numbers and you start, let's say, after this symbol here, so you print number 1, number 2, number 3, and so on. So then you arrive to 9, and that's fine. But then you arrive 10, so now you started to occupy 2 blocks. And then when you decrease this number and you don't erase with this command, but you just put the cursor here, what happens is just that the first thing becomes replaced, but the 0 is still there from the 10, because you just put the cursor here where the cursor is currently blinking, and then you just did a replacement there. So basically you increase this, but when you decrease the 10, instead of this, you get this, because the 0 is not modified. However, if you do this kind of operation, and you, let's say now you have the 10, so what happens is that this, and this becomes erased, because here we have 3 spaces. And then we jump back to this position here. So we are here, and enter 9. And that's all. So this is a better way. And if you would do the lcd.clear, that would erase your whole screen. So that's not a good idea. So what I say here is that jump to the position that you know that you want to modify, and then free up the space that you know that you will occupy. So if you are only expecting 3-digit numbers, you will need 3 space here. And then you jump back to the end position. You have to jump back, because after printing this, then your cursor will be at this point where now the cursor is blinking. So then with this line here, you put this cursor back to here, where it is located now, and then you can enter the value. And the same happens here, but this is the 2nd line, 3rd line, and 4th line. So this is very easy. And then we have the update cursor position. So this part is a bit tricky, and I did a very, let's say, simplified way. It may be ugly and not so efficient from programming perspective, but this was the simplest way that I could do it. And what I do is the following. So let's say we have this kind of structure here, and now we are standing here, but you never know if the user will move here or move here. And it was not obvious for me how to follow this in the most easiest way and redraw this. So for example, do something like this. So what I do here in the code, I will jump here and erase it, and then I will jump here, erase it, and then I jump here and erase it, and then I jump here and I erase it. And this happens so quickly that the user don't see anything. So now we have 4 empty lines, and that is the first block in each line. And then we come to this switch case statement, and based on the menu counter variable's value, which is 0, 1, 2, or 3, so this is line number 1, 2, 3, and 4, we will put the arrows back. So we see if we have the menu in the 0 position, then you put the cursor in the 0 position and print this again. or if it's in the second line, then we put the arrow there, and so on and so on. So this is what happens. So once again, everything is deleted, and then we just redraw the things based on the new position. And I think I explained this part, but yeah. So when one of the menus are selected, then we replace this kind of symbol with an X, and then we will know that now if one of the lines have the X, then we stepped into the submenu, and then if we start to rotate the rotary encoder again, then instead of stepping in between the different menus, we will increase the value of a variable within a menu. And basically this is it. So this was not so difficult, but it needs some attention when you are trying to implement these parts, and when you are trying to, let's say, set up the rules, how to print the different things, how to read the status of the button and the rotary encoder and so on. But it was very entertaining for me to work on this problem. And you could see that it works nicely, it's stable, and yeah, everything works as it should. So in the next videos which are related to this kind of problem, I will try to write a controller for a stepper motor, and I will also try to write a controller for my, let's say, digitalized Peltier cooler controller circuit. So basically this was all. I will upload the drawing of the circuit to my website, so please check the description or just visit curiousscientist.tech, and you will find this project as well as the source code. So if you visit my website, you will see the drawing and the source code as well, and you can download it and modify it for your own needs. I hope you learned something and this was useful to you. You will see more examples of this kind of code, because I want to further improve it, of course, and I want to use it in some more serious applications. If you want, you can donate my channel. You can see it on the picture how. And please don't forget to subscribe. That helps me a lot. And if you have some questions, please leave a comment and we can discuss it. So once again, I hope you learned something. I hope you liked this video and it was useful to you. And see you in the next video.